Hello everyone. In this video, I'm going to deploy multi-agent AI application. I have already created multiple videos on multi-agent application, but I used AutoGen 0.4 there. But in this video, I'll be using Semantic Kernel along with Azure AI Agent Service, where we'll use the Azure AI Foundry. First of all, let's start with what is Semantic Kernel. So it's a Microsoft open source toolkit using which you can create and manage the AI agents. In the semantic kernel, you can create a team or a group of the AI agents which will communicate with each other and provide you the desired output. So every agent will have a specific role to perform, and then they will work in a group together and then provide the output. So another service which I'm going to use is Azure AI Agent Service in Azure AI Foundry. Previously, creation of the AI agents was the problem. So Microsoft has launched a wonderful service named Azure AI Agent Service, using which you can create the different agents where you can perform different actions too, like document search using RAG or web search using the Bing or different other actions. And the best part is you don't have to manage the underlying infrastructure. Everything will be serverless. So you just have to create the AI agent and then use it in either the AutoGen or semantic kernel. So that was the introduction. Now I'm going to show you the project which we are going to deploy in this video. So we are going to deploy Building Planner AI application. I'm based out of Victoria, Australia. So in Victoria, if you're building any structure, then you need the building or the planning permit. And it's always very confusing because you have to call the council and confirm whether you need the building permit or planning permit, or can you create a structure like a pergola freestanding structure or not. So using this application, we are solving a real-time use case where users can get the correct information and then make a decision. So one of the agent will be document search agent, and we are applying RAG on it. So we'll upload the document related to building permit and planning permit, and then we'll vectorize that document. Whenever we ask any question, first this document search agent will look through the document and provide the answer. Another one is a web search agent, which will do the web search and provide the answer related to that question which has been asked by the user. Now, for some reason, Microsoft has stopped the deployment of grounded with Bing search in Azure. And that is the reason I'm using the SERP API, but instead of using it in Azure AI Foundry, I'm using it directly into the Python application using semantic kernel. And the third one is summarizer agent, which means the output from document search agent and the web search agent will be summarized by this agent, and then we will get the finalized outcome. Now there are two ways we can deploy this. First one is using the UI of Azure AI Foundry. There we can create the different agents and then use those agents into our Python application and then create a semantic kernel group chat. Another option is to create the agents using the Python code itself and then use them. So I'll show both the options, but for the whole project, I'll use the UI option. So let me show you all the steps in the lab how to deploy this application. I'm logged into Azure portal now, and I have already deployed the resources. So I have created the Azure AI Hub, and which creates the storage account where we can store the information or the data, and Key Vault for storing the credentials of the storage account. And once you deploy the hub, you connect it with the Azure OpenAI service. So Azure AI services is connected. And finally, once you are in the hub, then you create a project there. And I have created a project. So as you can see, this is the default name. I have created a project. So let's go to the project. Now the different endpoints are available here, the project connection string. And I have deployed one model which is supported by Azure AI Agent Service. So if we'll go to the models, there is GPT-4o model which is supported. And this is the model version, as you can see. However, the easy way is when you go to the agents, if there is no LLM deployed, in that case, you have to first create a model and then create the agents. So it has created an agent. So let's delete this. And perfect. Now we have the GPT deployed, but we don't have any agent right now. Let's open the VS Code. And I've already created the Python files. So the first one is the requirements.txt, where we need these specific packages, and for semantic kernel we need the Azure package. So once you install this, I have already created a virtual environment which I have enabled. So using Python -m v virtual environment, you can create the virtual environment, then activate it. Once it's done, you will install all the required packages using this command, pip install -r requirements.txt, and then all the requirements will be installed. So these are already installed. You don't need to worry about it. Another thing which you have to do is connect to AZ account. So you have to connect to your Azure subscription. I have already done that, but you can do that again. So it's connected. As you can see, my Visual Studio subscription is showing here. Now, as I told you, there are two options. We can create the agent using the Python code itself. So let's create the agent. So this is not the project. This is how we can create the agent I'm showing you. So first async IO, then Azure identity for the default credentials, then semantic kernel, so that we can create the Azure AI agent. We need to use asynchronous setting so that we can create the agent if it takes time. And now using the AI agent settings, we are creating the agent. This is a tech support advisor agent, and you are a helpful assistant that provides the technical support regarding Azure services. Once we define the agent, which will be created in Azure AI Foundry, then we create the semantic kernel agent using that agent. Once the semantic kernel agent is created, then we create the thread where the discussion will happen. However, in this case, we are not creating any group. We are just communicating with the agent. So my user query is, can Azure App Services be integrated with virtual network? Yes, that's possible. So in the thread, it will send messages, user query, and then tech support advisor agent will provide us the result. So once we get an output, the thread is deleted. However, in this case, we are deleting the agent also. So that means if you're deploying an application, you can create the short-lived agents. But in some scenarios where you need RAG or you need specific functionality attached with the agent, we don't want the agents to delete. So in that case, you can remove this option and then just use the agent which is already created, which we'll just see in another code. So let's try this. Python AI agent create py, and I'll quickly go to our code here. Let's refresh this. It should create an agent soon. And perfect. You can see the tech support advisor agent is created. And see here also it has provided the output. Yes, it can be done, and a concise output has been provided by the agent. So that means now using the code, whenever you need an agent, you create it and then you delete it. If you'll go back soon, the agent will be removed. If I'll refresh it, and it's gone. Perfect. So based on the different use case, you can create the agent and delete it. However, keeping the agent running doesn't create a problem because all the charges are incurred based on the number of times it's used or number of times it's called. So if you're keeping the agent, it doesn't affect anything. So now we have tested how to create the agent using the code. But now you have a different use case where you don't want to create an agent every time. So in that case, let's create the agent using the portal. Click on the new agent and the agent is created. It's super easy. You can give any name, test agent. And because there is only one deployment we have done, it has just picked up that one. Otherwise, you can create multiple. So you are a helpful agent which provides concise output. Okay, if you click somewhere, automatically it starts saving. It's saved now. You can add the knowledge, you can add different actions. I have already created a video on that, how you create the AI agents. But in this video, I'll show you how to use the knowledge, because we'll be creating an agent who will do the document search. But for now, that is enough. Now let's copy the Azure Agent ID and go back to our code. So let's click on existing. Same, it's async IO, then credentials, Azure credentials, semantic kernel. And now in this case, what it's doing is instead of creation, it's getting the agent. Now what we have to do is just provide the ID here, save it. And once the agent definition is defined, then we create the agent in semantic kernel, create the thread, and then ask the question. So let's run this. It's the existing one. Soon it will make a connection with the agent, and this is the user question or the user query, and it will provide an answer. And this is the output it has provided. And if you'll see here, there is only one agent which is used. We didn't create any new agent here. So now we have tested both the ways how we create the agent. Now coming back to our multi-agent application where we need three different agents. One for document search, another one for web search, and third one for summarizing the output. So I'll show the code quickly, but before that, let's deploy the agents. So click on this, or let's delete this, create from the scratch, new agent, document search agent. So this name doesn't matter. This is just for management purpose because it will be easy for you to manage with a different name. Otherwise, what we need is the agent ID. So let me add the document here. We'll upload the file locally. Select the local files. And there is one planning permit and building permit. So these are two documents which I have uploaded. I'll quickly show you these documents. So planning permit. This is Victorian government document which shows when the planning permit is required and all those details. Another one is for the building permit. So now the vectorization of this data will happen and I'll upload and save. And the best part is you don't have to manage the underlying infrastructure. It will be done automatically by Azure, managed by Azure. So all the vectorization, chunking, everything will be taken care. So now our agent is ready with the knowledge. So let's provide the system instructions. And if you click somewhere, so it's ready. So you are a helpful agent who provides information from the uploaded documents only. Keep the answer short and concise. Perfect. And now you can test it. Go to the playground. There is the agents playground. And this is our agent because we have only deployed one agent, document search agent. And let's ask, do we need planning permit for freestanding structure? So it should look through the documents only, not using its own knowledge. Perfect. It's looking through the document and it's provided that this information is available in the document. So that means our agent is working fine. Now we need two more agents. So one is created, another one is the web search agent. So let's name it as web search agent. But in this case, we are not going to add any knowledge or anything. We'll just add the system instructions. So I have added the system instruction that it's a helpful agent which rephrases the web search output because the web search output is sometimes too big and provide a concise result. Now there is an option of using the grounding with Bing search, which is not supported with this model. However, I have tried creating the grounded with Bing search in this subscription and Microsoft is making some changes. So Microsoft is not letting me create the service. So I'm using alternative, which is Google SERP API. So I'll use that. And we are not adding it here. We'll just add it into our code. So another agent ready. Now the third agent, which will be summarizer agent. and I'll provide the system message. We are not adding any other additional information here. It summarizes the inputs given and provide a meaningful and understandable way, and keep the output concise. Simple. And now we have three agents which are ready to be used. So let's go back to our code. And the third one is multi-agent code. So let's understand this code. However, don't worry about the code. I'll upload everything in the GitHub, and you can find the link of the GitHub in the description of this video. We need async IO, AIO, HTTP, OS, and all these are required. That's why we have requirements.txt. Then we are loading the environment variables. So let's check the environment variables. And project connection string, SERP, API, agent model which is deployed. So these are required here. And then we need to provide the agent 1, agent 2, agent 3 ID. So agent 1 is our document search agent. Let's provide the ID here. Then the web search. And finally, the summarizer agent. Perfect. And then we are getting the environment variables, SERP API, SERP endpoint, project connection string. And now we are adding the search web query too. So it's using the SERP API. So you can go to their website, SERP API. So Google search API. And I have the API available. So once you will register, you can get that API easily. It's very easy to get it. So I have provided that API. And then using the SERP endpoint, I'm getting the result of the web search. So for the user query, I want it through the terminal. So as soon as I'll run this, it'll ask me the question. And it's using the credentials, connection, it's making the connection to the project and getting the details from there. So three different agents which are defined: document search, web search, summary agent. And it's getting those agents and then finally creating the agent in the semantic kernel. So once three agents are created along with the web search result, as you can see here, then the thread where all these will chat with each other using the different chat messages. And finally, it'll delete the thread and provide us the output. So let's run this. So it's multi-agent Python. It should ask me question now. So now you have to enter the query for planning and the building permit. Can I create a pergola without approval? So let me ask this. So as you can see, the project client is initiated. So semantic kernel is initiated now. Okay, it failed because I'm not supposed to provide the space. So I've fixed it. I've gone back and let's add underscore everywhere. So it's saved. Now the last one. Perfect. So we have underscore here. Hopefully this time it should work. Let me copy what we are asking. So can I create the pergola without approval? So let's try again. Yep. Let's provide our question. Project client is initiated now. And perfect. So the document search agent response is there. So it will provide a concise response that there are certain criteria that has to be filled. Now the web search agent also searched the web and provided this information. And finally, it has provided as a summary that to build a pergola without a permit, specific conditions typically apply. So it should not be higher than this, and it should not cover 20 meter square area and all those regulations. So based on the response from document search agent and the web search agent, the summarizer agent has provided this information. and that is perfect. This is what we wanted. So now there are endless use cases you can create with this, where these agents will communicate with each other, correct each other, like review each other's output and then correct it based on your liking, and then you can get a desired output. So that's all I wanted to show in this video. I hope you liked it. Please like and subscribe. Thank you so much.